Assalamu alaikum students. I'm a teacher from Ilm Online Academy. In today's lecture, we are going to talk about the approximation and estimation. So, approximation basically is the value that is close to an exact value. Okay? Approximation will be close to exact value. But if we would be talking about the estimation, basically estimation is a rough calculation and it will roughly give us the idea that will be again closer to the answer. So this will be basically going to give you a rough value. Okay. Approximation, we can give an example according to approximation in this way that, for example, if we want to round off a number to the nearest 10, sometimes nearest 100, sometimes nearest 1000. So we can use the term approximation for that. For example, if we have a number like 2.91 and I want to round it off to the nearest whole number, so I can round it off up to 3. So this is basically the approximation. But if we would be talking about the estimation, that would be the calculated answer, but we need to sometimes round it off. For example, we know that 3.4 and 5.5, if we will be add them both, this will be 8.9. But the estimated answer for this will be 9. Like I round it off up to the nearest whole number, or even you can round it off to the one decimal place as well. So basically this is the difference between the approximation and estimation. So we will be using these things to round off a number to the nearest of something. For example, nearest 10, nearest 100, nearest 1000 in this way, or to get any decimal place, like first decimal place, second decimal place, or to just round it off a number up to the certain number of significant figures. So let's talk about significant figures a little bit. So significant figures. Significant figures are basically those, there are some rules that we can use to find out a number if that is a significant or not. So, like basically, we would be talking about the first three rules that are the important rules according to the significant figures. First rule is this, that zeros are not the significant, and other than that of zeros, all the numbers will be significant. Like we have 453. In this, basically, there are three significant figures. Okay, why three significant figure? Because here we have three non-zero numbers. So if we have the numbers like other than that of zero, they all will be significant. Second rule is this, that if we have a number like the zeros in between a number, so these zeros will be also significant. Like here, if I will be counting the significant figures, so 1, 2, 3, 4, 5, there are basically 5 significant figures. Okay, but if we have been given the zeros at the start and we needs to talk about the significant figures over here, so only two significant figures are over here. Okay, starting zeros will not be counting as the significant figures, only the zeros that are basically in between or ending zeros. Like for example, if I have 5000, so I will be counting as four significant figures over here. Okay, so these are basically the rules that we will be using for finding out a number up to the nearest significant figure. So let's start this exercise, and the exercise is 5.1a. So in the first part, what they're saying that write the following numbers correct to the one A part is to the nearest whole number. So first of all, like all the numbers that they have been given from 1 up to 15, we need to write them to the nearest whole number as well. Next, we need to write them to the nearest three significant number. And the C1 is that each of this part you will be rounding it off up to two decimal places as well. So one by one, all these three things we will be doing with each and every part. So the first part of exercise 1.5a is 1 point, no, sorry, this is basically 8.174. So as for like A part is concerned, we need to just round it off up to the nearest whole number. So if after the decimal point, exactly after the decimal point, you have a number like 5, 6, 7, 8, 9, like greater than that of 5 if you have any number. So you will add one number in the previous one and this will become 9. But if you have a less number, like for example, we have 1, either 0, 1, 2, 3, 4. So then you will not add one number in the previous number. So the whole number for this will be 8. This will be the nearest whole number. Okay. Next, similar number, if I want to round it off up to the three significant figures, so I need to have three numbers. And all the numbers are other than that of 0. So for that, we need to go on up to three numbers. And after this number, we need to check what number is this. So that is basically 4. So if 4 is there, so you will not add one number in the previous number. So only you will be taking the number as 8.17. These are your three significant figures. Okay. Next, for the C1 part, we need to round off the number up to the two decimal places. So two decimal place means that after decimal point, you need to have only two numbers. So again, we need to check for 7, and after 7, there is 4. So 4 is again less than that of 5. So that's why you will not add one number in the previous number, and only you will be taking at 8.17 again. These are basically the number up to the two decimal place for the part number C. Okay, so in this way, one by one, we are going to round off the numbers, sometimes according to the significant figure rule or sometimes according to the decimal place rule. So let's move on towards the second part. And the second part is basically 19.617. So for this, we need to first of all round this number off up to the nearest whole number. So the whole number is 19 that they gave before decimal point. But as after this decimal point, the next number is 6. So if you have 6, you need to add one number in the previous one number. So that will be 20. Okay, this will be the nearest whole number for 19.6. Next, for the B part, we need to round off the number to the nearest to the three significant figures. So these are the three significant figures, 19.6. And after 6, there is 1. So no need to add one number in the previous one. So the number will be simply 19.6 only. Okay. Next, the part C, that we need to round off the number up to the two decimal places. So after decimal point, there must be two numbers exactly when we are going to round it off. So the two numbers will be 6, 1. And after 1, there is 7. It means that you need to add one number in the previous one number. So this will be 19.62. So this is a way to round off the number up to the two decimal places. If you have the number, like the number that you need to round off, if you have a number greater than that of 5 or 5, including 5, and greater than that of 5, so you will add one number in the previous number. So in this way, you can round off a number up to a required decimal place. Okay, let's move towards the third part as they gave us 20.041. So the first part is that we need to round off the number to the nearest whole number. So again, this number is 20, and after this there is 0.0. So no need to add one number in the previous one, just simply you will be writing 20. That's it, okay? B1 part is that we need to round it off up to the three significant figures. So the three significant figures will be 20.0 because the zeros are in between, so you can count them. So it's 20.0. These will be three significant figures. And the C part is up to the two decimal place. It means that after decimal point, there must be exactly two numbers. So that are 0, 4. And after 4, there is 1. So no need to add one number in the previous one. So the number becomes 20.04. This is your two decimal place number. Okay, next we need to move towards the fourth part. And the fourth part, the number that they gave is 0.81452. Okay, let's move with the parts. So first is that we need to round it off up to the nearest whole number. So 0 is being given before decimal point. So after this there is 8. So 8 is greater than that of 5. So we will be adding one number in the previous one and your whole number will becomes as 1 only, okay? B1 will be the three significant figures we need to check. So after decimal point, you need to check three significant figure because 0 is at the start are not significant. So 1, 2, 3, these are three significant figures, but after 4, there is number 5. So it means that you need to add one number in the previous one. So you will be writing it as 0.815 rather than that of 4. Okay, next C part is that we need to round it off up to the two decimal places. So if I will be checking the two decimal places, so there will be 8 and 1. And after that there is 4, so you know need to add one number in the previous one, and your number will become 0.81. So this is basically the number up to the 2 decimal place. Okay, next, moving towards the next part, we have this fifth one part over here. So let's move towards that. In the fifth part, we have the number as 311.14. So again, for this as well, first of all, we need to check to the nearest whole number. So the nearest whole number checking will be before decimal point. The number is 311. And after that, the decimal point, we have only 1. So no need to add one number. In the previous one only, we need to write as 311 as our nearest whole number. Next, for the B, three significant figures are only these three significant figures before decimal point we are getting. And after that, there is 1. So again, no need to add one number. In the previous one, we are again getting 311 for the part B. For the C part, we need to write the number up to the 2 decimal place. So after decimal point, already we have two numbers. So we will be taking all these two numbers. So 311.14. This is basically my 2 decimal place number for part number 5. Okay, now randomly I'm just picking up some questions. So accordingly, you can check whatsoever they will be remaining. You can try them yourself. So we have 0.00744. So for rounding it off up to the nearest whole number, as we have 0 and after that there is only 0.00. So my nearest whole number will be also 0. Okay, because like after decimal point again we have zeros. So that's why 0 is also a whole number. Next, we need to round it off up to the three significant figures. So you can check that at the start we have zeros. And before zeros, after zeros, we have 744 that are already three significant figures. So we need to write the complete number because zeros at the start will not be the significant. Only these three numbers will be counting as three significant figures. Okay. Next, the part C, we have to write down the number up to the 2 decimal places. So for writing down the number up to the 2 decimal place, we need to check the two numbers after the decimal point. So the decimal point numbers will be 0, 0, but after that we have 7. So you can add one number in the previous one number, and in this way you will make the number as 0.01. So this is your 2 decimal place number because after decimal point we have two numbers. Okay. This is your part number 7. Okay, let's see for part number 9. I'm basically picking up the questions randomly. We have 900.12. So let's go on with the A part. We need to round off the number to the nearest whole number. So that will be 900 only because after decimal point there is 1. B is up to three significant figures. So these zeros that we are having over here, they are basically coming in between. So for that you will be taking them both, and after that there is 1, so no need to add one number in the previous one. Next is up to the 2 decimal place we need to go on. So 2 decimal place, already the number is given up to the 2 decimal place, so you would be taking them all. Okay, so this is basically your part number 9. Okay, let's move towards part number 13. In 13th part, they have been given a number as 0.0851. Okay, so first of all, again, we need to round it off up to the nearest whole number. So that will be 0 again. Why 0? Because after decimal point, there is 0 again. So no need to add one number in the previous one. Next, B1 is three significant figures. So three significant figures, 0 at the start are not significant. So only they give three numbers, so they will be all significant. So 0.0851. These are the three significant figures. So you will be writing them all. Next, we need to go up to the 2 decimal place. So these are the 2 decimal place number. And then we need to check that after that what is the number. That is basically the number 5. So we will be adding one number in the previous one. So the number will become 0.09. Okay, so this is a way of writing a number up to a nearest whole number, significant figures, and 2 decimal place. So hope so this one part is clear. Okay, next they're saying write the following numbers correct to the 1 decimal place. For all of these numbers, we need to just correct them up to the 1 decimal place. Only one number will be after the decimal point. So let's start this. we have 5.71. So as after one first number, we need to have 5 or more than 5. So only then we will be adding one number in the previous one. So you can only write 5.7 for the 16th part. Okay, next for the 17th one, we have 6 after the first decimal number. So we will be adding one number in the previous one. It will become 0.8. This will be only 11.2 because after that there is 4. This will be as 0.1 because after one first decimal place there is 6. Next, this will be as 0. Okay, this here we have two zeros after the decimal point. You can check, so only 0.0 because no need to add one number in the previous one. Here again 11.1. So these are all the numbers up to the one decimal place, and this is your exercise 115, sorry, 1.5a. So moving towards the next exercise, that is basically according to the measurements and bounds. So basically we are having the two bounds. One is the upper bound and one is the lower bound. So upper bounds and lower bounds are basically giving us a range for a number. That will be basically the length for the basic number. So there are some rules or tips here you can use for writing a number up to the nearest bound, either upper or either lower bound. Okay, so here are some tips that if you have been given a number like the unit is 1, so you need to add half of a number and you will subtract half of a number as well. Like for example, if I have a number 13, this is my 1 unit number. Okay, like no decimal places at all over here has been given. So what you will do, you will add or subtract 0.5 in this. You will add 0.5 in this and you will subtract 0.5 in this as well. Upper bounds we can get after adding 0.5 and lower bound we will be getting after subtracting 0.5 from that. As one example they gave of for the number 145, and they're saying that the length could be measured as 145 centimeter to the nearest centimeter. So for this they are finding out the lower and upper bound. So for lower bound, we need to subtract zero point 0.5, so it will be 144.5. And for finding out the upper bound, we need to add zero point 0.5, so that will be 145.5. Okay, this is basically your first 1 unit number. Next, if you have been given a unit like 0.1, so we need to basically half of a unit will be added in this, like the half of 0.1 will be 0.05. And next, if they have been given a unit like this, so you need to add again half of the unit, that is 0.00005. Okay, so these are basically the tips that we are going to use to find out the lower and upper bound for the numbers. So exercise is quite easier one, just we need to better check that how to find out the upper and the lower bounds of the number. So let's start. The first question for exercise 1.5b is that in a DIY store, the height of a door is given as 195 centimeter to the nearest centimeter. Okay, so the first part is they have been given us the height, that is 195 centimeter, and what they are asking for, and this is to the nearest centimeter, so write down the upper bound for the height of the door. So we need to find out the upper bound, and for finding out the upper bound, like this is 1 unit number, so in this 1 unit number we need to add 0.5 because upper bound we need to find out, so that will be 195.5 centimeter. So this is basically your upper bound. Okay, just this thing you need to find out over here. Next, moving towards the second part, in this they're saying a vet measure the mass of a goat as 37 kilograms to the nearest kilogram. We need to write down the least possible mass. So least possible mass means the lower bound. So what they gave us is the mass of a goat, and that was basically 37 kilograms. And we need to find out the lower bound. Again, the number that they gave is according to the 1 unit. So from this 37, we need to subtract 0.5 this time. This will be 36.5 kilograms. So this is your lower bound for this second part. So hope so this is clear to you. Third one part is, so in third one part, what they're saying, the farmer's scale measures mass to the nearest 0.1 kilograms. because the unit that they gave is according to the 0.1 kilogram unit. So what is the upper bound for the mass of the chicken, which basically scale says that it has the mass of 3.2 kilogram. So the number that they give is 3.2 kilogram, and that is basically again the mass. So mass has been given as 3.2 kilograms. And the nearest unit that they gave is 0.1. So if I will make half of 0.1, basically that will be 0.05. So this is basically the unit that we are going to add or subtract. As they're asking for upper bound, so it means that we need to add this unit. So for finding out the upper bound for this mass, in 3.2, we need to add 0.05. Okay. So according to this, the number will be 3.25 kilograms. Okay, this is your part number 3. Next, moving towards part number 4, we have a survivors using the laser beam device that can measure the distance up to the 0.1 meter. Again, the similar unit they gave us just the way they gave us in part number 3. And they're saying the least possible length he needs to find out, and the length of the warehouse is this meters. What they gave us over here is the length, that is 95.6 meters, and we needs to find out the lower bound. And for finding out the lower bound, the unit that we will be using is exactly similar, just the way I just found it over here. So in 95.6, we need to subtract this time 0.05. Okay, previously we were adding, but now we will subtract. So this will be 95.55 centi. Okay, the unit is given in meters, so we will be writing it in meter as well. Okay, so these are the first 4 parts of your exercise 1.5b. Hope so they all are clear. And in these parts, we need to just find out the bounds, either lower or either upper. So let's move towards the next part. So next in part number 5, what they're saying that in basically in the 200-meter race at the school, Stephanie was timed as 28.6 seconds. This is basically the time that Stephanie used to go on with the race. And this is basically correct up to the 1 decimal place. If you can carefully check the number that they gave us up to the 1 decimal place, it means that the unit that we are going to use will be according to 0.1. This will be the unit that we need to use, okay, for this part. So what they're saying that we need to find out the upper bound for her time. So here basically the time is related that we need to go on with. So let's go on with this 5 parts. So we have the time that Stephanie used, that is 28.6 second. And as the unit that they give is of 0.1, and the half of 0.1 again is 0.05. So it means that 0.05 again we need to use over here. So for that we need to find out the upper bound. So let's go on with this upper bound. So for finding upper bound, in this 28.6, we need to add 0.05. So after adding 0.05, it will be 28.65 seconds. And as they gave us the second, so we will be writing the answer in seconds as well. So let's move towards the 6th part. And the 6th part, there's you need to copy and complete the table, sometimes with upper or lower bound for the numbers according to the given different scales. So A part is temperature in the fridge is equals to 2 degrees Celsius to the nearest degree. So as this one is basically the number is as a whole number, like one unit number they gave, for finding out the lower bound from this 2, we need to subtract 0.5. And for finding out the upper bound in 2, we need to add 0.5. So 2 negative 0.5 will be 1.5. This will be your lower bound, and upper bound will be 2.5. Okay, next is the mass of an corn. So that is 2.3 grams up to the 1 decimal place. So for the 1 decimal place, again similar this unit we will be using. So in from 2.3, first we need to subtract 0.05. So that will be 2.25. Okay. And next, for finding the upper bound in 2.3, we need to add 0.05. and that is basically coming 2.35. Okay, so this is up to 1 decimal place. Next, for the C part, we needs to go with the length of the telephone table, that is 64 meter to the nearest meter. Again, they gave us one unit number. So from 64, first of all, we are going to subtract 0.5 and it will be 63.5. And for finding our upper bound, we need to add 0.5 and it will be 64.5. Okay, this is your lower and upper bound for 64 meter. Okay, next is the time taken to run as 100 meter, that is basically 13.6 seconds. So to the nearest 0.1, as because after decimal point, they gave us 1 decimal place number. So what we will do, similar unit we will be using here as well. So first of all, from 13.6, we need to subtract 0.05. So after subtracting 0.05 from 13.6, it will be 13.55. And next, for finding out the upper bound in 13.6, we need to add 0.05. So it's coming 13.65. This is your part number D. So next, moving towards part number E, they're saying the time taken to do my homework is 45 minutes, correct to the nearest 5 minutes. So if like we will be checking this one E part, the number that they gave is 45 minutes, and this is basically related to the nearest 5 minutes. So if we would be checking the unit according, so half of 5 will be 2.5. It means that we need to add and subtract 2.5 in this. For finding out the lower bound from 45, he needs to subtract 2.5, and that will be 42.5. And for finding out the upper bound in this, you need to add 2.5 and it will be 47.5. So these are basically the lower and upper bound, and this table is basically giving you a clear idea that how like we can use the units to go on with the lower and upper bounds using this strategy. Okay, so this is your complete part number 6. So let's move on to the next. So moving towards part number 7. So in this part, what they are asking that the length of a carton of milk is measured as 193 millimeters to the nearest millimeter, and so the length lies in between A, B, or C. Like lower and upper bound both, they are just asking for the range. And as this is 193 millimeter, that is nearest to the 1 unit number. So we need to add and subtract 0.5. So that will be 192.5 and 193.5. So accordingly, B is the correct answer. Okay, because this is 1 unit number. Okay, next part number 8, they're saying the mass of a suitcase is 35 kilograms, nearest to the kilograms. Again, similar unit they gave us up to the 1 unit. And what they're asking, the mass lies in between. So we need to check carefully that which one unit will be the better unit. So first is 30 to 40. So this is basically exactly not according to this part. Okay, that they gave us 34 and 36, that is according to the 1 unit, and 34.5 and 35.5. So here C will be the correct part because 1 unit number is again like either you need to subtract 0.5 or either you need to add 0.5 to get the upper and lower bound of the numbers. So this is your part number 8. So hope so this is clear. Next, we need to move towards the part number 9. So in this, they're saying that Edra and Laila that each measures a different worm, and they both say that their worm is 11 centimeter long to the nearest centimeter. Both worms are having this one length according to their perception. So in A1 part, they're saying, does this means that both worms have the same length? Like this is basically the estimation that they are just talking about, their approximate answer according to the nearest centimeter. So this will be not necessarily similar for both of them, so it's not exactly fine. So we can say this, not necessarily. Okay. Next part B is that they're saying if not, what is the maximum possible difference in the length of the worms? As they're asking for the nearest centimeter, so this will be only according to the 1 unit difference. 1 centimeter. This can be the difference, okay? Because they are asking that what could be the nearest centimeter then. As this is 1 unit number, so according to 1 unit, this will be 1 centimeter. Okay. So this was your part number 9. Let's move to the next part. So here we have part number 10. In this part number 10, they're saying that to the nearest centimeter, the length L of a stapler is 12 centimeter. So as an inequality, you can write this as 11.5 and 12.5 up because this number is according to 1 unit again. 1 unit. So we need to add 0.5 and subtract 0.5 as well to get this range exactly. So they're saying for part A to J, they gave us the parts over here. They're saying they have given some measurements. So we need to write the possible value as an inequality just the way they give us above. So let's find out one by one. So A1 part is that in A1 part they're asking the mass is 17 kilograms and they're saying that you need to write it down up to the two significant figures. So 17.17 if they have been given, so it means that this is basically the 1 unit place number. So accordingly, the part number 10 I'm doing here, a part the 1 unit number. So we need to add or subtract 0.5 from this. Okay. So for this, first of all, finding out the lower bound, we need to subtract 0.5. It will be 16.5. And as this is math, so I'm using m over here. And for basically upper bound, we need to add 17.5. Like 0.5 we need to add and 0.5 we need to subtract. Okay. Next part number B, they gave us D as 256 kilometers to the three significant figures. So here as well, like again, they gave us a 1 unit number. So we need to add or subtract 0.5 in this as well. So 255.5 for the lower bound. And for upper bound, we need to write 256.5. Okay, so here at the place of M, we need to write D because they gave us the number in D part. So D will be also fine. Okay, next is C. Length they gave us 2.4 meters. So as they gave us the 1 unit place number, so one decimal place number will be according to basically 0.5. Okay, so accordingly we can check from 24 if I'm going to subtract the number according to one decimal place. So what will be the number? Like here we need to add or subtract 0.05. Okay, this. So accordingly, first of all, we need to check the lower bound. So let's find out. From 2.4, we need to subtract 0.05 and it's coming 2.35. And for adding 0.05, after adding, I'm getting 2.45. So this is basically the lower and upper bound up to one decimal place. Okay, next part, D, they gave us again the mass. And they're asking for lower and upper bounds. First is 0.34 grams. So for finding out this, as they gave us up to like two decimal place, so two decimal place will be 0.01. This will be the unit up to two decimal place. And as we need to add half of the unit, so 0.01 and half of the unit is basically the number that we need to add or subtract is 0.005. So first of all, for finding out the lower bound from this 0.34, we need to subtract this 0.005. So let's find out. What I'm getting is 0.335. And adding 0.005 in this, I'm getting 0.345. So this is your lower and upper bound for the part number D. So let's move towards part number E. In part number E, we have 2.04 as up to two decimal place again. So up to two decimal place again, similar number, similar unit we will be using to add and subtract. So first we need to add For the lower bound, we need to subtract 0.005 from this 2.04. So accordingly, I'm getting 2.035. Okay, and from this we need to subtract 0.005, and after that we need to add 0.005. So for this I'm getting 2.045. This is part number E. Next, moving towards part number F. In F, they gave us X, and up to one decimal place only they gave for the F1 part. So the number is 12.0. So first will be 11.95, the lower bound. And the upper bound will be after adding 0.05 in this. So that will be 12.05. This is basically for the part number F. So let's move towards the part number G. In part number G, they give us the temperature, and for temperature, we need to check the lower and upper bound, and the number that they gave is basically 81.4, and this is up to one decimal place. So the lower bound will be after subtracting 0.0, 0.05 from this. So accordingly, we are going to get 81.35. And after adding 0.05, we are getting 81.45. So this is basically lower and upper bound for G part. Next, part number H. Okay, for this, we have M. So the number is again up to one decimal place, that is 0.3 for H part. So again, for H part, we need to add 0.05 and we need to subtract 0.05 as well. So the lower bound is coming 0.25 and the upper bound is coming 0.35. This is your lower and upper bound for part number H. Next is part number I. So here they gave us the mass again. So for part number I, we have 0.7 as the number. So for lower bound, we are going to have 0.65 after subtracting 0.05 again. And for adding this, we are going to write down at 0.75. So this is your I part. Next, moving towards the J part. In J part, they gave us 52,000 and we need to go on up to the nearest thousand. Okay, let's go on with this. We have part number J here and they gave us N. Okay, so as we have been given 52,000, so for this, we need to add or subtract a different number in this. So this time, so we need to add or subtract 500 in this. Okay, when they give the number in this way. So first of all, adding 5,000 or subtracting 5,000, let me show you as well. 52,000 subtracting 500 and 52,000 adding 500. So let's first of all subtract this. So this will be 51,500. And after adding 500 in this, it will be 52,500. So this is basically your part number J. Next is part number K. The number is 220 minutes to nearest 20 minutes they are asking for. So the nearest 20 minutes, 20 half is basically 10. So 10 we need to add or subtract over here. They gave us the time. For finding out the lower bound from 220, we need to subtract 10 and it will be 210. And for finding out the upper bound in 220, we need to add 10, so that will be 230. So this is your K part. So hope so this is getting clear. Next is this part number I, or sorry, no, this is L basically. So the number that they gave is 2,750. So we need to find the lower and upper bound for this in this number, as they're saying that you need to round it off to the nearest 50. So half of the 50 is basically 25. So we need to add or subtract 25 in this. So first of all, subtracting 25 and then adding 25. So subtracting 25 is going to give us 2725. Like half of the 50 will be 25 again. And next by adding 25, it will be 2,775. So this is basically your part number F. So hope so this complete part is clear to you all. In part number 11, they gave us a statement. They're saying that a card is basically measured as 11.5 centimeter. Here they give us a card. This is basically the measurement, and this basically is up to the nearest 0.1 centimeter. And they're saying is to be posted in an envelope that they gave us with the length of 12 centimeter long to the nearest centimeter. So can you guarantee that card will fit inside the envelope? We need to explain your answer. So first of all, what we will do, like as they gave us the card length as well, and they gave us envelope length as well. So we can check that what will be the maximum card length. Okay, maximum card length, and we can check the minimum envelope length. If they both will be according to the measurement, so we will be checking that either it will fit in or not. Okay. So first of all, card length they gave us part number 11. They gave us the card length, that is 11.5 centimeter. So first of all, we will be checking for the nearest card length or the maximum card length or upper bound for the card length. And they gave us to the nearest 0.1. So we need to add 0.05 in this for finding out the upper bound. Or you can simply say maximum card length. In this way, this will be more clear to you. We are going to find out the maximum card length. So for that, in 11.5, we need to add 0.05. So after adding this will be 11.55 centimeter. This is your maximum card length. Next, they gave us the envelope length. So envelope length is being given as 12 centimeter. So for envelope length, we will be checking that what is the minimum envelope length according to this. So this will be according to the lower bound of the envelope. So minimum envelope length. So for finding out the minimum envelope length, basically they gave us the number as 12 centimeter up to the nearest centimeter. So if this is one unit number, so only we needs to subtract 0.5 from this. This will be 11.5 centimeter. So let's just predict that either there will be the possibility or not. So the card length maximum is 11.55 and the minimum envelope length is 11.5. So you can check the difference that the card length is basically a bit greater than that of the minimum envelope length. So this will not exactly fit inside this envelope. So you can say that no, the maximum card length is 11.55 centimeter and minimum envelope length is 11.5 centimeter. So that's why what we can say, no, we can't guarantee. And for the explanation, basically this working will be with you. That this is your maximum card length and this is the minimum envelope length. So this is your part number 11. Hope so this part is also clear to you all. So this was your exercise 1.5a and your exercise 1.5b. So for exercise 1.5a, basically you must have the concept of these three concepts that are basically the decimal place concept, significant figures concept, and the whole number concept. These three concepts must be clear for rounding off any number. Okay, second thing, like for finding out the bounds, you must know the units and like which basically the number you need to add or subtract if they have been given the particular unit. Okay, sometimes the unit are being given up to the one decimal place, sometime a whole number they gave, sometimes it's up to the two decimal place. So in this way, you can just divide your given unit according to two each time to check that which number you need to add or subtract to get your lower and upper bound. So if these things will be clear to you all, so these exercises will be very easy. So hope so this exercise is clear to you all. So see you up till the next lecture. Allah Hafiz.